Hey, welcome back to another episode of JavaScript Jabber. This week on our panel we have Dan Shapir.
Hello from very hot Tel Aviv. Well, isn't that a surprise? Summer in Israel.
Right. It's also pretty hot here. It's been getting up to 100 degrees, which is like 40, 41 degrees Celsius.
That's actually hotter than it is here. So we've got it better.
It's been that way here for over a month. It's been
frying your eyeballs?
Just about. Anyway, I'm Charles Max Wood from Top End Devs, and we're going to be talking about monitoring and alerting using Prometheus and Grafana. Now, I've played with Grafana. This was proposed by Dan, and so I figured he's probably going to do most of the talking. But yeah, just to give a little context, I don't even know what Prometheus is, so yeah.
Yeah, so to backtrack a little bit before we get into specifically what Prometheus and Grafana are, I want to talk a little bit about monitoring, alerting in general. I've been working on stuff like performance monitoring and performance optimizations for a good number of years now, as you all know if you've been listening to this podcast. And probably one of the most important lessons that I've learned is that you need to have monitoring in place and alerting in place before you start any work on improving things. And in this context, I love a quote from Peter Drucker. Peter Drucker more or less created the field of business management. And the quote is, if you can't measure it, you can't improve it. And I'm really a big fan of that. If you're unable to measure something, there's really no way for you to know if you're making progress, if you're improving things, or if you're actually degrading things or making no impact at all. And one of the things that I've done in this context is that whenever say I join a new company or start a new project, I often find myself under pressure to start delivering improvements, from the get-go as quickly as possible. And I always push back on that in order to make sure that we have proper data collection and proper monitoring in place before we start making any improvements. By the way, in this context, it's probably not surprising that I joined Sisense, which is a BI analytics company, because I'm really a big believer in that. And, as an extra benefit, if you're doing this kind of work, one of the big benefits of having some sort of measurement and monitoring solution in place is that after you've made improvements, you'll have graphs to show the impact of your hard work. And from my experience, that's really beneficial when let's say you're looking for a raise or advancement or something like that. But really, in order to be successful in any project that requires taking a system and trying to, let's say, improve it, then having some sort of a monitoring capability in place is crucial. Now, the question obviously then becomes, what do I actually use for that? I mean, it's fairly straightforward to collect a lot of data these days, but what do you do with it? Where do you put it? How do you process it? How do you visualize it, etc.? And in this context, I want to talk specifically about two things, which are Prometheus and Grafana. And first, I'll start with a riddle for you, Chuck. Do you know, like, who Prometheus was?
He was a titan that brought us fire, right? In Greek
Wow.
mythology, and he was punished by having an eagle eat his entrails out for eternity,
yeah, exactly.
Or something like that.
He was tied to a mountain I think with the Tartarus Mountains, and then Zeus's eagle would come once a day and eat his entrails, and because he's immortal, he cannot die, so he suffers forever. By the way, later times, Greeks or Romans kind of thought that this was like too bad of a fate, so they had Hercules release him or something along these lines.
Right.
Um, but now I can't prove it, but I think that the reason that this project was called Prometheus is because it's about bringing knowledge. Because fire in this context is like
Right.
synonymous with knowledge, knowledge from the gods to the humans. So it's about
Right.
bringing knowledge to us developers about how our systems are operating. So that's the mythology about of what Prometheus is. Now let's talk about what Prometheus the service is. So Prometheus is free software, as in open source that you can install on premises or you can use as a service, I think, as well. That is used for event monitoring, alerting. It was originally created something like 12 years ago at SoundCloud when they came to the conclusion that none of the third party solutions for monitoring were sufficient for their needs. And after they built their system and used it internally, about 4 years later, they donated it to the Cloud Native Computing Foundation,
Right.
which is the same foundation that also hosts the Kubernetes project. So,
Mm-hmm.
this is another successful project from that foundation. I think the people who are mostly working on it these days are the people from the company that does Grafana. But again, it's open source, and you can see the source code on GitHub, and there are a lot of contributors. Um, I actually personally contributed to one of the satellite projects around Prometheus, which is the Prometheus client for Node, which makes it possible to connect Node.js to Prometheus in order to
Right.
monitor nodes. So I contributed specifically to that part of the project.
I'm going
Um,
to stop you just for a minute. Um, I've been posting the links in the comments, but they don't go to X, and that's where most of our live listeners are. So Prometheus is prometheus.io, and Grafana is at grafana.com. So anyway,
mhm. Yeah, that's true. Okay, so where were we? So we were talking about a little bit about the history of Prometheus, both the
mm-hmm.
mythological figure and the project. Now
Right.
let's talk a little bit about what it actually is. So it's a service used for event monitoring and alerting. It records real-time metrics in something called a time series database, which is kind of a special type of database, and we'll talk about it in more detail and how it differs from the databases that most of us are familiar with. It allows for something called high dimensionality, which I also will try to explain. It supports flexible queries and real-time alerting. And as I said, it's free software. It's licensed under the Apache 2 license. So that's what Prometheus is. So let's
Right.
say you want to use Prometheus in your organization. What you would do is that you would install the Prometheus service and then hook it up to your various services that you want to monitor. Now, it's a monitoring solution for backend infrastructure. So things like Node.js or for the JVM or for something, let's say, written in Go, because that's not surprising because Prometheus itself is actually written in Go. So maybe
Right.
it's a shame that we don't have AJ on the show this time.
Yeah, maybe. But your point is that any language or system could have a driver that pushes data into
Yes,
Prometheus.
there's basically a connector for anything. There are also
Right.
connectors for a lot of general services. So if you want to monitor, let's say we were talking about Kubernetes, you can monitor Kubernetes. Kubernetes has a built-in
Mm-hmm.
connector for Prometheus. So you can look at how pods are functioning or the Kubernetes cluster itself. There are
Right.
connectors for various AWS services, and so on and so forth. So you can collect a lot of data from, third-party services and infrastructure, and you can also attach it, like create applicative level monitoring. So you can monitor the behavior of your own applications that are running on platforms such as the JVM, such as Node.js, or in Go, etc.
Right.
More or less any programming language that you can think of. Now, the way that you configure the system, so again, not very surprising given perhaps that it's written in Go, the configuration are YAML files. And again, this is kind of correlates with Kubernetes. Um, so YAML, for those of our listeners who somehow don't know, is a configuration format. You can think of it in to an extent, kinda, sorta similar to what we usually do with JSON files, but it's a different format. It has certain advantages over JSON. For example, it supports comments.
Right.
Um, it's used by a lot of for a lot of administrative stuff. So any DevOps person is likely very familiar with YAML.
The default configs for Rails are all done in YAML as well. So,
Hmm. Yeah. So you basically create configuration files for Prometheus in YAML. And the way that Prometheus works is kind of the reverse of what you might expect. So you might think that you somehow configure various systems to push data into Prometheus, but that's not how it works. The way that it actually works is that Prometheus pulls data into itself. So in the YAML file, you tell Prometheus the addresses of the various services that you wanted to monitor, and the rate at which it should effectively ping those services. And it effectively does an HTTP GET to an endpoints exposed by these services and downloads data from them. So it actually
oh,
pulls the
cool.
data from them into itself. Now, the advantage of this approach is that, first of all, they don't need to be aware of where the Prometheus server is.
Right.
So it's all the configuration is centralized. They just need to open the port, listen on it, and that's more or less it. It also means that they can work with multiple Prometheus service servers at the same time because they all just pull the data. Because pulling the data doesn't clear the data. It's not as if, they give the data and then forget it. They retain the data. Those services are expected to retain their data in memory, so you can just hit any one of them at any time and pull from them their current state. I hope that's clear.
Yep. Makes sense to me. I kind of like it too, just from the standpoint of, so I've used other systems, paid systems. We've been sponsored in the past by Sentry and Raygun and stuff like that grab a lot of this information. Though I think we're talking kind of a level below that, right? Where we're not talking specifically about the information that's being sent. We're just talking about how the information gets into the system at this point. I like the fact that it's like, okay, I'm going to periodically check, and then I don't have 10 million hits on the service on the other end, right? Because I'm not pushing it to it, it's pulling it. And so it only does the work that it has to do, right?
Yeah,
And I
yeah,
don't have all this extra network crap going on.
yeah. So it basically does an HTTP GET, let's say once every minute to any
Mm-hmm.
one of those services. The response is essentially text in their own format. It's quite readable actually. So you could literally go to one of those endpoints and just hit it with your browser and see what the response would be. By the way, obviously, you probably want to make sure that those endpoints are not externally exposed.
Mm-hmm.
So you know that everything stays behind the firewall.
Right.
The one kind of caveat to that is that sometimes you have like short-lived services. Think about something like a Lambda.
Mm-hmm.
In that case, what they have is something called a push gateway, which is like a standalone service that those short-lived jobs can push data in because they are really short-lived.
Right.
So you can't assume that they'll hang around until they're pulled again. So they can push their data into that push gateway, which holds onto that data, and then Prometheus pulls that data from that push gateway. So it's kind of
That-
an
yeah.
intermediary service that for those special cases. But in most cases, and the cases that I've used it in, it was with long-lived servers or services, and then that's just the way it worked.
Right.
Uh,
That makes a lot of sense too. Just in the yeah, like I'm thinking like serverless functions and things like that. Or if we've also run background jobs a lot in the apps that I have, right, where it pulls it off the queue and then runs it. And so yeah, in either of those cases, yeah, you don't want or necessarily need something hanging out so that it can say, oh, you're going to query me within the next minute or so. It just says, poof, I'm done, and then hands it off, right?
yeah. So there's, for example, in the case of Node.js, there's a Prometheus client for Node.
Mm-hmm.
Uh, I think it's literally, the project is literally, as I recall, called Prom Client. So you just npm install it, and then it's in there. You you just give it the port to listen on, and then it does all, it, let's say it uses Express or something like that, and then it basically collects the information and exposes that to that port for you, and you don't really need to do anything to start monitoring basic system level stuff.
Mm-hmm.
um, Now the Prometheus server gets the data in, and then saves it into its own persistent database.
Right.
And that database is what I call the time series database.
Mm-hmm.
Um, and what I mean by that is that Prometheus doesn't store data, like, don't think of it something like a database. We tend to think of something like a relational database or
Right.
maybe a NoSQL database. That's not really that sort of a thing. It's something called a time series database. So basically, it has metrics, and it basically saves the value of a metric at every point in time.
Mm-hmm.
So it's really like keeps on collecting metric data. So there's no such thing really as schemas or something like that. It just has metrics that it collects data into, and it's data collected over time. So like, think of, I don't know, let's say you're a farmer, and you've got a field, and you're measuring the temperature in the field. So you've got the temperature measurement, let's say every minute, that you got
Mm-hmm.
from the whatever, the thermometer device that you use to monitor the temperature, and it just gets recorded into that persistent storage. And you can go backward and forward in time and look at any point in time what the temperature was.
Right. So I'm trying to imagine what this looks like for an app. So is it measuring like how much CPU it's using and how much memory
Yeah,
it's
so
using,
we'll get so
along
we'll
with some of the other? Oh, we'll get into
yeah,
that. Okay.
yeah, we'll get into that. But basically, as I was saying, you can
I'll
think
I'll
of
keep my enthusiasm down for a minute then.
it you know what, let's talk about that a little bit. So it's really monitoring two types of information. One, you
Okay.
can think about it as system level stuff. So
Mm-hmm.
in the context of Node, a Node server, that might be CPU usage, or memory/heap usage, or event loop lag, or if it's an express service, the number of requests per period of time, or the duration of the responses, stuff like that.
Okay.
So those are system level things, and they're collected for you automatically. So as soon as you npm install the prom client for Node, and it is loaded into your project, your Node server, then all that stuff is automatically collected for you. And when the Prometheus server hits that port, that information, those metrics are available from the get-go. On top of that, you can add applicative level metrics that you push into Prometheus using an API. So, for example, if you've got like your own, let's say, queues, internal queues that you want to monitor the usage of, or your own business logic processes that you want to measure the duration of, you can measure those as well. Okay? So you've
Hmm.
got both the system level stuff and the applicative stuff. Um, and by the way, one system level stuff that is really important in the context of Node and maybe less obvious or familiar to some of our listeners is something called the event loop lag. Are you familiar with that?
I am not.
So, as you know, the way that JavaScript works is that it's all
Hmm.
based on an event loop, uh,
Right.
be it either in the browser or in Node. JavaScript, the way that it works is you've got whenever something happens, like if it's in browser, then it's something arrives over the network, or so the user does some sort of an interaction, a mouse click, a keyboard press. Whenever something happens, an event is triggered, and that puts the event information in a queue. And JavaScript, which behaves in a runs kind of in a single-threaded type approach, pulls data out the top data out of the queue, processes it, and then moves to the next item in the queue, next item
Hmm.
in the queue, and so forth until, if the queue becomes empty, then it effectively idles until another stuff is put into the queue. So far, so good.
Yep.
Now, the problem is that usually, rather than idling, what happens really is that information gets into the queue at a very rapid pace, at a high clip.
Hmm.
So it might new events are placed into the queue before the before the JavaScript engine is ready to process them because it's still busy processing other stuff. Like
Right.
you think about, let's say, a node server running Express. The events coming in are the HTTP requests. If HTTP requests arrive at a too high rate, then the node service might not be able to process them quickly enough and will get overloaded.
Right.
So, what the event loop lag actually measures is the amount of time from when a message is placed into the queue until it's taken out of the queue in order to be
Okay.
processed. So, if that period of time is small, then you know that your service is really responsive. If it
Hmm.
gets to be too high, that it means your system is overloaded and it's not responsive enough. If
Right.
think about a service, an express service that takes I don't know, 2 seconds to pull something out of the queue, it means that the client side is waiting for 2 seconds before its event is even processed. So obviously that's a
Right.
bad thing, and it's especially bad if it keeps on growing, because then eventually your server will just become unresponsive.
Right.
So that's information that Prometheus, that the system, the Prom client, is actually able to extract out of Node and exposes that into Prometheus. So that's one of the system monitoring things that's really useful to look at when you're monitoring a Node service. Another thing that's really useful to look at is, for example, heap usage. Because
Hmm.
if you've got, let's say, some sort of memory leak, then
Right.
you'll see that after a garbage collection, a GC, rather than going all the way down, your memory utilization keeps going up and up and up and up.
Hmm.
And again, that if it keeps on going, what will happen is that the the node service will try to do GCs more and more and more and more in order to free memory, but fail to do so, and you get what's known as a GC storm, where effectively the service, all it does is just try to free up memory that it can't, and it becomes totally stuck. So that's another
Right.
thing that you can look at in the context of Prometheus.
Well, it seems like on both of those measures, on the lag in what is it, node event loop lag,
Exactly.
it seems like, because I'm sitting here and I'm thinking, okay, so it's going to tell me if it doesn't have the resources to handle whatever's coming at it. But for me, I find it useful because, I mean, let's just take podcasting for an example, right? Like, I don't go and religiously obsess over the numbers, right? I don't go look at the metrics. But for an app, if you're checking the metrics on a regular basis, it seems like you could start to see this lag, event loop lag steadily increasing, and go, okay, we are getting to the point where we need to start looking at, right, instead of all of a sudden being whoa, we're way over the edge, right? And so it allows you to be proactive, right, instead of reacting to people are complaining it's slow.
Yeah,
uh
and actually, what you really want is to have good alerting, and we'll get to that
right.
as well.
I
Because
was gonna, yeah.
yeah, because realistically, you're not going to check the graphs for all your
Hmm.
services every morning or every
Right.
afternoon. What you really want is you want a system that alerts you in case something is wrong. And you usually want an alert to say not that, the system is broken. You want an alert to tell you, you know, system is running hot. Uh, you,
Hmm.
you should do something before it breaks.
Right.
And yeah, and Prometheus is great for that as well, because you can specify alerts, and so that's the other part. So I was talking about how all the data is collected into the Prometheus service and then saved into persistent storage, but
Right.
then you can also do queries on top of that data. Prometheus has its own query language. It's called PromQL, and it
Hmm.
looks nothing like SQL. Even though it's a query language, it's a totally different query language. No
Well, GraphQL
similarity.
is the query language, and it doesn't look like SQL either.
Exactly. And you can do two sort of things. You can have Grafana as a visualization environment. So Grafana is the
Right.
service that you run in the browser, and it can show you all sorts of graphs from various data sources. And one of the data sources is Prometheus, and you can write PromQL queries that extract data and then graph this data in whatever dashboard you're using. So that's one possible usage. Another possible usage is something called the Alert Manager, which is another component of Prometheus that comes along with it. It's a standalone service that does at regular intervals it runs PromQL queries, gets the data from them, and sees if alerting criteria are met. And if they are, it can then push alerts into emails or Slack or PagerDuty or whatever, so that you can generate alerts out of the Prometheus data. So, for example, going back to that farmer and field and thermometer example, you could say that if the temperature goes above, I don't know, 30 degrees on the ground, send an alert, something along these
Hmm.
lines.
Yeah, that makes
Uh,
sense.
yeah. So
That
when,
I just want to throw in here real quick, because I think sometimes we kind of treat the time series data as kind of monolithic in ways like treating it like for the day or the week, right? I was actually looking on the Discord server that we use for the hosts, and um, Adventures in DevOps, they were going to do an episode where they were talking about holiday rushes, right? And
Mhm.
so one day to the next, it may vary, or you may get a lot of your traffic in the morning or the evening. And so, by having these alerts, you can start to pick up some of the patterns, And the other thing is you can turn around and you can say, okay, I not only do I know that something's happening now, but I can go look at the current state of things or get a snapshot from the Prometheus data and then start to solve whatever is the issue is, right? Whether it's I need more resources or, oh, I didn't realize, but I built something into the application that makes it memory heavy. And so my heap size is going out of control and I'm running out of memory or whatever.
For sure. But definitely also the fact that data can vary over time, even if regularly, can make some of this stuff pretty challenging, but still
Yeah,
doable. PromQL is a
right.
very sophisticated query language, and I'll give examples of some of the challenges that I've run into when creating alerts. So, for example, at a lot of companies that I've worked, companies like Wix or Next Insurance,
Hmm.
there was a lot more traffic, let's say, over the weekdays than over the weekends, um, which is not surprising. But the downside of that was that data over the weekend would fluctuate a lot more because the sampling size was significantly lower.
Mm.
When you think about it, let's say you have, let's say, talking about Next Insurance, so you might have 10,000 sessions in a week, in a weekday, in a working day,
Hmm.
but only 100 over the weekend.
Right.
And when you've got only 100 sessions, then 10 bad sessions can really impact your performance numbers.
Mm.
So, and then we would see that we, if we weren't careful, we would start getting alerts over the weekends because the data was less stable because there were just fewer sessions. So
Right.
we basically kind of had to come up with queries that were also dependent on the number of sessions, not just the duration of the sessions. So if there were too few sessions, we would ignore the other criteria of the duration of the sessions. So
Hmm.
that might be something, it makes the queries more challenging, but you want to take these sort of things into account. So quickly going back to, when is Prometheus a good match and when isn't it a good match? What type of data would you want to put into Prometheus and what kind of data you would probably want to put somewhere else. So Prometheus is a good match when you're recording pure numeric time series data.
Okay.
It's appropriate for machine-centric monitoring, you're monitoring systems. When it's highly dynamic service oriented architectures, because this whole pull type in mechanism makes it very easy to adjust to additional instances coming up or going down in a very dynamic sort of a manner. And again, I'll talk about it assuming we have the time. uh, Something about, it's very important when the data is multidimensional, and both in the collection and the querying, and I'll explain what that is a bit later on. Now, when is it not a good match? First of all, it's not a good match when you need 100% accuracy. So, for example, if you're looking at stuff like billing, when the numbers have to be perfect, uh,
Hmm.
then Prometheus is not a good solution. Prometheus, in most cases, kind of averages out data, because again, when you're looking at stuff like CPU usage, it doesn't really matter if you're running at 93 or 93.2 or even
Right.
94%. But if obviously, if you're looking at stuff like your taxes, you probably need to be accurate.
Don't
It's
remind me
not a
about
pro.
taxes.
Sorry.
They said, "Don't talk to me about taxes right now."
Yeah, yeah. Anyway, it's also not appropriate when you're recording non-numeric data. So, for example, if you're recording stuff like email addresses or phone numbers, even though they seem like they're numeric, they're not really.
Right.
Or street addresses, stuff like that. That's not appropriate. And it's also not appropriate when the data has to be totally persistent, when it's you can't afford to lose any data. As I said, Prometheus pulls the data out of the various services at regular intervals, let's say every 1 minute. If that service crashes during that 1 minute, you've lost the data since you
Hmm.
previously pulled it. And that's obviously not something that you can live with in a lot of cases where you need persistent data. And if you're dealing with bank accounts and stuff like that, you can't afford to lose transactions or stuff like that.
Yeah,
So
but it seems like most people are using it by putting this client onto their application, and so it's only recording those specific kinds of data. You're talking about a custom use of Prometheus where you might push other data into it as well.
Exactly, exactly. Now it can be a challenge because again, let's say you're pulling the data or pulling it in every minute, and if your
Hmm.
server has a problem that in a certain scenario memory consumption like rockets out of control and then the server crashes, then you might not be able to catch that if it happens within the span of a few seconds. So you can either then try to increase the rate at which you pull and hope that you're lucky, or look at for some other solution.
Right.
As I said, it has integrations for Node, JVM, Go, Python, Ruby, and in terms of systems, stuff like Kubernetes, GitLab, AWS, Jira, MongoDB, Redis. For visualization, usually you'd use Grafana, even though it also has its own built-in simple visualization capabilities.
Okay.
And it's compatible with OpenTelemetry. So if you're using OpenTelemetry for collecting telemetry information, you can also use OpenTelemetry on top of Prometheus and have OpenTelemetry put its data, the data that it collects, into the relevant data, the uh, the time series data into Prometheus. So there are several types of metrics, and they're appropriate for different scenarios. So very quickly, going over the different metric types, you've got something called a counter. Think about, the if you're let's say, think about a club, let's say that you want to go into, and there's somebody at the door with this kind of a counter device, clicking it
Hmm.
every time somebody goes in, like counting the number of people inside, because the fire regulations only allow up to X number of people to be inside at the same time, and they need to count the number of people going in and the number of people coming out to make sure that they don't exceed those limits. So a counter is really something like that. It's a metric that that can only increase, and you basically add one, or add an n, which is like adding one
Hmm.
n times. So you basically just add into it, and it keeps on getting higher. Can you think about things that you would measure using something like a counter?
Yeah, like the number of requests that come in or
So,
the number of
funnily,
queries you make.
that's literally the first example that I have. So the request
Yeah.
count is exactly such a thing. Tasks
Right.
completed, error
Yep.
count, all these kind of things that only go up. They only increase until at
Hmm.
least until you restart the service.
Right.
And the cool thing about a counter is that because of this behavior of only increasing, you can compute the rate of increase, which makes it possible to have predictions. Because if you can calculate the rate, then you can also predict where you'll be in a certain amount of time.
Right. Makes
Uh,
sense.
Yeah, so that's the simplest type of metric. Again, it's used automatically for things like a request counter or a task
Hmm.
complete counter or an error counter, stuff like that. But you can also create your own applicative counter if you want to count your own stuff.
Right.
The next type of metric is called a gauge,
Hmm.
and it records a value that can go up or down, or literally be set at any value that you want. So you can literally say the value of this gauge right now is X.
Hmm.
Again, can you think of when you might use the gauge?
This would be like cue size or
Chuck, are you
things like.
looking at my slides?
Nope.
Because again, that's the the first item that I have on my slide for using it is the queue size. Exactly. Um, queue size, memory usage,
Right.
CPU usage, number
Yep.
of requests in currently in progress, all these
Hmm.
sort of things that you just set it to a particular value at each point in time.
Right.
Now, the key so it can go up and down or be set to a particular value. The thing
Okay.
about it, though, is that because it's so arbitrary, you can't use it to assess rate of change. Because if you can just jump between numbers, there's no
Right.
real meaningful uh, um, rate that you can think about.
Yeah. You can average it out, but
Yeah.
yeah.
The next one is slightly more complicated, and when I actually have presentations that I do that I so far have done internally. I'm kind of looking for a conference who wants to talk about this. But if you want to be able to measure things like histogram, like averages, or even more importantly, percentages, like the median or the 90th percentage or stuff like that,
Hmm.
then you use a metric called a histogram. Now, that might seem surprising why it's called a histogram if it's used to measure percentiles, for example, and I'll
Hmm.
explain it. I'll try to explain it in a minute. But can you think about when you want something like percentiles?
I would think like memory usage or
No,
I
memory
mean you're
usage, we talked about counter. When do
no,
you
what I meant was, or percentage of like memory used or percentage of resources used.
so what they have is
Maybe I'm
something
not
like
understanding what it is.
so I'll give examples, and I think that then it will click for you. So think about something like a request duration. Like
Oh, I
you want,
gotcha.
so you want to say like my median request
I gotcha. Yeah.
handling duration is X, or the 90th percentile is Y. Another
Right.
example might be the response size. So
Hmm.
you might say my average response size or my median response size is such and such. It goes up to something else when I'm looking at the 99th percentile.
Hmm.
Um, so you kind of want to be able to get the measurements, but then use them in order to calculate, as I said, percentiles.
Right.
Now, it's called a histogram because the way that it's actually implemented is that internally you create buckets. You can say, let's say you're talking about request duration. You'd say, I have a bucket from 0 to 10 milliseconds, from 10 milliseconds to 50 milliseconds, from 50 milliseconds to 100 milliseconds, and anything above 100 milliseconds. Okay. And each
Hmm.
measurement goes into one of these buckets, and then you look at how many fell into each one of those buckets, and then you can use it to calculate percentiles.
Right. No, that makes sense. So
So it's like a
just to kind of give
histogram for
people.
each point in time.
Right. The thing that I'm imagining is anything that you would put like on a bell curve or something like that, right? And so then
Yes.
your 90th percentile is, out on the end, right? But so these are kind of rare, but they're also kind of the extreme that you have to deal with, right?
So
Versus what the
so
medium or whatever is
it's
in
a
the middle.
histogram. It's a histogram that gets recorded and updated at every interval. So it's like
Right.
a histogram over time.
Oh, interesting. So you could literally see like the hump move or whatever in
Exactly.
your.
You say, this is my histogram now. This is my histogram a minute later. This is my histogram another minute later, and so on and so forth.
Interesting. Okay.
So hopefully that's kind of clear. Now there's another metric called summary. I don't want to get into it. It's more rarely and uncommonly used, so we'll skip it for now. We're starting to run long in any event. Because
Right.
what I really wanted to talk about was the concept of labels and dimensionality. So let's
Hmm.
go back again to that field example of the farmer wanting to measure, let's say, humidity and temperature in the field,
Right.
in their field. But it's a big field, so they're not using just a single measurement device. They've got devices spread out in different locations in the field.
Right.
So one way in which you might think about it is that we'll create a separate metric for each one of those measurement devices.
Hmm.
But the way that Prometheus looks at it is that we've got a single temperature metric, but for each measurement, we associate labels with it. And that label is textual value. It might be the name or the ID of the specific measurement device. So let's
Hmm.
say I've got four devices in the field. They're called A, B, C, and D. I've got the single temperature metric, but each measurement is associated with either A or B or C or D.
Hmm.
Is that clear?
Yep.
So now, what's the benefit of this approach? Is that it's very dynamic. If I buy some more land and I now
Hmm.
need also an E and F measurements, I don't need to create new metrics. It's the same metric,
Right.
but it's associated. But there are the new values coming in are associated with new label values. So I've got a label called, you know the device name, but it
Right.
can come in with any arbitrary textual value. And then when I query the data, I can say, show me just the values for the metric for measure for when the label is equal to A, or
Hmm.
to A or B, or A and B, because when you do queries in the PromQL query language, you can either set a label like in the query to have a specific value, or use a regular expression.
Okay.
So you can
So
have
I'm imagining that you could do this if you're spinning up, say, another Docker container or server.
exactly. So you might have the pod name. You would have a label called pod name, and the value is the name of the pod.
Right. Yep.
And you can have any number of labels associated with each metric. And those labels can have any number of values.
Okay.
Now, that I think highlights the potential issue of dimensionality, because it makes the system very flexible,
Hmm.
but you'll see the problem in a minute. So let's say I have a metric and I have three labels associated with it. So
Hmm.
it's actually, they defined a three-dimensional space for that metric, because each
Hmm.
measurement has a coordinate that is specified by the values of those three labels.
Okay.
Is that clear? I'm kind of
Mm,
waving my hands. Think about
a
it.
l-
So think about, again, going back to the field example. Let's say that instead of having each measurement in the field have its own name, it has a coordinate in the field. So it has an x-axis, an x value, and a y value. So it's a
mhm.
two-dimensional space.
Okay.
Now, now in reality, like again, when you're measuring things, you might have many more labels than that, so it becomes an
Hmm.
n-dimensional space.
Right.
And if for any so and the for each axis, the number of points on that axis is the number of different values that label might have.
Okay.
So let's say I have three labels and each one has 10 potential values, how
Hmm.
many how many different numbers in that space can I have?
1,000.
Exactly. So I need to remember 1,000 different numbers for that single metric.
Right. And make sense of it, hopefully.
Yeah, but the problem is that if I'm not careful with the number of labels that I use, and especially the number of different values that each label might have, I can literally blow up my memory.
Right.
And again, going back to how Prometheus works, that Prometheus pulls, let's say you have a node server, and Prometheus pulls the data from the node server once every minute. So know that node server keeps all that data in its memory.
Oh, okay.
If you're not careful, you'll blow up Node's memory. If you've
Right.
got, so I'll give a real example. We were using Prometheus to monitor data associated with the page performance at
Hmm.
Next Insurance, and so one of the labels was the URL.
Hmm.
We had something like 2,000 different pages.
Okay.
So we had a label called, so one of the dimensions was um, was the URL, and it had 2,000 possible different values.
Right.
Actually, if we weren't careful, it could have had a lot worse if we didn't filter out uh,
Query
uh,
parameters.
query parameters and stuff like that. Exactly. Um, and another label that we had was device type, because we wanted to
Hmm.
distinguish between desktop and mobile.
Right.
And another label that we had was the browser, the
Hmm.
browser type, because we wanted to distinguish between performance, let's say, on Chrome and on Safari.
Right.
So think about it. It's 2,000 different URLs times 10 different browsers times three or four different types of devices or five types of devices. And all of a sudden, and for each one of those three dimension coordinates, you need to remember a metric. So it's a number. So it's
Hmm.
millions of numbers that you
Right.
need to,
Right.
that you're holding on in memory. And we literally kind of blew up the memory space.
Right.
Uh, so yeah. So you need to be careful when you're like cavalier about the number of labels and dimensions that you're using. So it's called cardinality, and basically
Mm.
you need to beware of high cardinality.
Right.
But the benefit is that that system is extremely flexible. Like
Right.
if there's a new URL, you don't need to do any modification in the system. It automatically adjusts to that because it just
Right.
associates a label value with that particular, another label value with that particular metric.
Right.
Um, Now, there's all sorts of things about naming conventions. I won't go into that. Um, about how you name your metrics and how you name your labels. I won't go into that. Um, I will say that there's a really cool API for working with all the different metric types. So we talked about counter, engage, and histogram. So you can there's if you um, import the prom client npm package, then you
Hmm.
get those apis that you can push your numbers with associated labels into the system, and they just get recorded.
Right.
So again, you might have, let's say, some sort of business logic process that that hits, does all sorts of things, goes to one database, goes to another database, does all sorts of things, and you want to measure its duration overall. Or
Mm-hmm.
maybe you've got your own like custom queue for something, and you want to measure the size of that queue, or you've got something like that, um, or a pool that you want. Let's say you're utilizing your own custom pool of resources, and you want to make sure that you've made the pool not too big, not too small. Then again, you could be looking at the size of that pool and how many, what's its utilization at each point in time. So you can, through those APIs, measure your own business logic values. And
Mm-hmm.
the example that I gave is we were actually using it to measure core web vitals. If you remember, we've had a lot of
We've
um,
had, yeah, a lot of
guest
conversations about it.
Exactly. Now, those are metrics that are actually measured on the browser side. So you might ask, how did they make their way into Prometheus? Well, we would collect this data on the client side, post it to the node server, and the node server would use that API to put it into Prometheus.
Right.
So this way you can collect data not just from the node side, but also from the browser side. Again, it could be a
Mm-hmm.
system level stuff like Core Web Vitals, or it could be applicative stuff. You know, whatever your web application happens to be doing that you would
Mm-hmm.
like to measure and monitor.
That's cool.
Yeah. So now the final piece that I wanted to mention is how to get data out of Prometheus. So as I
Mm-hmm.
mentioned, there's a query language called
Right.
PromQL. That's PROMQL. And like I said, it's definitely not SQL. It can do stuff like factoring data, aggregating data, run all sorts of predictive functions, tech quantiles, which is a fancy name for percentiles, and
Mm-hmm.
averages and whatnot. And it can be used to answer questions like, what's the 95th percentile latency in each data center over the past month?
Right.
So very sophisticated queries. Or
Mm-hmm.
how full will the disks be in 4 days? So here's an example of a predictive query.
Mm-hmm.
Or which servers are the top 5 users of CPU? All these
Okay.
sorts of queries. And you can either use these queries in order to graph things or in order to create alerts.
Okay. And that's what
So,
Grafana does. Is
yeah,
it
so
uses PromQL to do this stuff?
exactly. So in Grafana, what you do is you create a graph, and in the graph, you specify Prometheus as the data source,
Okay.
and you write the PromQL query, and then it basically graphs that query over time.
Mm-hmm.
And it has all sorts of fancy graphs. So you can do like line charts and bar charts and heat maps and all sorts of really fancy graphs. And it's really powerful. Um, if you're interested in this sort of stuff, I highly recommend just going into YouTube, let's say, and searching
Mm-hmm.
uh, um, for PromQL. There's also on the Prometheus website. There's like there's documentation and tutorials for PromQL as well. So we can post links to that later on in the notes. Um, Obviously, if this was a talk, then I would actually be showing examples of PromQL, but
Right.
I can't really do that. Uh,
You're
but
not going to read
suffice
it
it.
out loud?
Exactly. Um, so you would put PromQL in one of two places, either in something. So actually, one of three places. So the Prometheus itself has its own simple web interface where you
Mm-hmm.
can put in PromQL queries and get data either in tabular as basically just numbers, tabular representation of numbers, or in
Hmm.
simple graphs. If you want much more sophisticated graphs, then you can use Grafana. And Grafana actually has a pretty sophisticated editor for PromQL, so it does automatic completion for you. It knows all the metrics in the system and the labels and the different label values, so it can actually do autocomplete for you when you're typing in the queries. Um,
Nice.
yeah, it's really nice. It's, as I think I said, it's kind of, they're kind of sister projects, so it's the same people working on both of them, so they made sure that the integration is really nice. And you can also use the PromQL in the alert manager, where you would type the queries in the YAML files, and
Hmm.
then they get run automatically at periods. And if they come back with data that matches the query, then an alert gets raised. So you run a query. If it comes back no data, no alert. If it comes back with data, then there's an alert. So the query, an alert query might be, um, the number of CPUs that are at utilization higher than 80%.
Right.
And if the number is zero, then there's no alert. If the number is greater than zero, then there would be an alert.
Makes sense.
Something like that. And it's actually even more sophisticated than that, because you can say you want to avoid like peaks, momentary peaks. So you might say it needs to be higher than 80% over a period of 2 minutes,
Right.
stuff like that.
Makes sense. Yeah.
So it's a
So,
very sophisticated and powerful system.
so is this something? It sounds like something you used at Next Insurance. Is this something that you're using
We're
today,
also,
or
yeah, we're also using it at Sisense. So, for
okay?
example, when we deploy our service, our customers have the ability to run our services um, on premises, and
Hmm.
then they can collect monitoring data for our own services inside an instance of Prometheus that we install with it.
That's cool.
Um, but like I said, it's a really powerful system, and it's really flexible. And again, if you want to do monitoring or alerting, and probably you want to do both, then
Hmm.
it's a very good solution for that.
Nice.
And that more or less covers it. Like I said, I have a talk, a presentation on it, in which I am able to show actual examples and visuals. So
Right.
it's more informative. If you're interested in that, if you're running a conference and you're interested in that, I'm shopping this talk out.
Nice. Well, I mean, this is something that I've kind of been contemplating figuring out how to put into my own systems, right? I mean, I send data into, I have a self-hosted version of Sentry is the thing I've been using lately. And it collects some of this kind of data, but I've
Uh,
gotten more and more into self-hosting my own kind of thing and running through some of this, right? And it sounds like this is right, kind of right up that alley too, where it's okay when I deploy, right? It just it makes sure that I have a Grafana and a Prometheus instance set up that it just reports to.
Exactly. Now, obviously, there are overlap between these sort of systems, but I
Right.
think their focus is kind of like not exactly the same. So,
Right.
let's say if you're doing like error logging, then Sentry is the tool for you.
Yeah.
I think I said that Prometheus is not the appropriate tool for textual information. So if you're
Right.
looking at stuff, you're like keeping stuff like stack traces and stuff like that, then you want to use something like Sentry. You
Yeah.
could theoretically count the occurrences of a particular type of error, But
Hmm.
yeah, you probably want to use Sentry for something like that. Also,
Yeah.
Sentry has stuff that's specifically intended for performance monitoring in certain
Right.
scenarios. But if you want to do more general purpose monitoring and system level monitoring, and monitoring applicative stuff, then Prometheus could be the solution for you.
Right. I also like that, as it aggregates that data, effectively what you can learn from it is only limited by, I guess, what it's measuring, but also what you can come up with to query out of it.
Oh yeah, for sure. I created some amazing queries using PromQL. Like, so I'll give that example. So at Next Insurance, we had something like 50 services in a service-oriented architecture,
Hmm.
so which were communicating with each other over various API endpoints, and
Right.
we wanted alerts to be fired when when any endpoint in the system became too slow. But then the
Hmm.
question was, what does too slow mean? Because
Right.
it can't be absolute numbers, because if something, it usually takes 50 milliseconds and then all of a sudden grows to 100 milliseconds, that means it's too slow. But if something always runs at 100 milliseconds and then becomes 110, well, that's a smaller change and you might want to ignore it.
Right.
So you can't look at absolute numbers. So I created really sophisticated queries that basically looked at behavior over time and tried to see if something became significantly slower compared to its own specific behavior from
Mm.
previous durations. And also, again, wanting to only look at those endpoints which were sufficiently used, because if there was some endpoint that was hardly ever used, then we probably don't care about it.
Right.
So yeah, so
That
you
makes
can
sense.
create really sophisticated queries like that. And it was exactly because with all these endpoints, you don't want to have to tell somebody, a developer, where, well, you know, you're in charge of a service that has 100 different API endpoints. You need to look every day at 100 different graphs to figure out if there's a problem. You
Right.
want so you want an alert to be sent to that
Right.
to the Slack channel, let's say, of that particular team, if any one of those endpoints all of a sudden became slower in a way that really potentially impacts the system as a whole.
Right.
And yeah, that's the one of the projects that I did at Next Insurance. And we
That's
use
cool.
and we use Prometheus and Grafana for that.
Very cool.
So when alert like that was sent to the Slack channel, the on-call member of the team could actually click a link, see the graph for the
Hmm.
performance of that endpoint in Grafana over time, and say, okay, we actually have a problem, or no, this is just
Right.
a fluke or something that we can ignore.
Yeah. Yep. It spiked for such and such a thing and no big deal.
Yeah, we were doing something. We ran some sort of a backup service, and that's
Right.
why it impacted everything. And
Right. Or you migrated some data on the back end and it slowed it down for 2 minutes and then,
exactly.
yeah. Awesome. All right. Well, we put some links into the comments on Twitch and YouTube and Facebook. If you want to go find those, we'll try and get them into the show notes as well. But let's go ahead and do some picks.
For sure, although I don't have that many. Um, okay, I actually do have something. So, for some inexplicable reason, I decided to start tweeting out um, my favorite standalone fantasy novels or books.
Uh huh.
Fantasy tends to be written as lengthy series of books or at least
Mm-hmm.
trilogies. But occasionally, I just want to read one book that stands on its own merit, on its own,
Mm-hmm.
because it starts and it ends, and you can move on to something, to the next thing. So I started to tweet out my list of the top standalone fantasy books, and you know what? I'll use each. I'll pick each one at a time. So let's see, which one was my
Ooh.
first? Can you think of one? There's the obvious choice, by the way, which is, I think, The Hobbit.
I was thinking that, but then I was like, I don't know if he considers that part of a series because it is sort of a prequel to Fellowship of the Ring and that series, that
Yeah,
trilogy.
yeah. I
But
think
it's
it
its own
is.
self-contained story. Yeah.
Yeah, first of all, it's totally self-contained, and the second important thing is that it was written well before Lord of the Rings was written.
Yes.
So
Yeah.
Tolkien actually wrote The Lord of the Rings because the publisher was so happy with the success of the Hobbit that they wanted more stories in that world, and it was his idea to transform it from a child's story to a story
Hmm.
for grown-ups. But so
Right.
The Hobbit was originally written for his children, although a lot of adults like that story as well.
Oh yeah.
You know what? I'll tell you another interesting story about the Hobbit. So there's a so there are a couple of translations of the Hobbit into Hebrew, but
Hmm.
the one of the translations is especially interesting. It's called the Pilot's translation, because because during so there was a war between Israel and Egypt in the early 70s, like in between
Hmm.
the Six Day War and the Yom Kippur War. There was kind of, it's called the War of Attrition, and various pilots were downed and captured by Egyptians and held as POWs for several years, kind of like the American POWs in Vietnam.
Hmm.
And they were looking for ways to pass the time. And one of them got their hands on the English version of The Hobbit, the original Hobbit, and they decided to translate it into Hebrew as a way to pass the time. So, and when they were released, they took the translation with them, and it literally got published, and it's called the Pilot's translation of The Hobbit
That's so
from
fascinating.
from English into Hebrew. So anyway, so The Hobbit would be one. So, but because that's the obvious one, I'll give another one, and that book is called Tigana. It's by Guy Gravell Kaye. Interestingly, to kind of close the loop, he's the person that worked with Tolkien's son on bringing it on, publishing the Silmarillion. So they had a lot of
Oh,
notes left
interesting.
over. Yeah, they had a lot of notes left over from Tolkien. So they actually took all those notes and kind of rounded out and filled up the story, and then released it as the Silmarillion after Tolkien had died. And he worked with Tolkien's son, but he also wrote several books on his own. One of them is a standalone novel called Tigana. You might actually find it especially interesting because it's very much inspired by um, by the Renaissance Italy. So the
Huh.
setting there, it's a fictional world, obviously, with magic and and stuff like that. But the situation, the scenario is very reminiscent of Italy in the Renaissance, with the little countries warring principalities and influenced by larger external powers and so on and so forth, and the culture and whatnot. And it's a great book. It's amazing the amount of story and settings and scenery and characters that he was able to cram into this one book. It's a pretty thick book, but still one book, and it's very highly recommended. As I said, it's called Tigana. That's Tigana by Guy Gavriel Kaye, and that would be my pick for today.
Awesome. I'll have to check that one out. Um, we were watching the Lord of the Rings movies, and my daughter was saying that she'd never read them, and so I had it on Audible, and so she's been listening to it. So,
But if she's already watched the movie, can she get into it?
I think so. She's pretty into other like Harry Potter and Percy Jackson, and
Hmm.
she got into the books too after she'd seen the movies. So,
Cool.
yeah, I'm gonna jump in with some picks. Now I have to say my board game group hasn't gotten together in a little bit. Um, it's just kind of that season of life. But what I'm trying to think of a game I should pick. What was the game that we played last Sunday with the kids? I don't remember. Anyway, I mean, there are all kinds of games out there that you can play. I'll just go with one of my favorites. It's funny because I've never actually completely played through this game. No, I take it back. I have played through it once. It's called what's it
Monopoly.
called? Monopoly.
Does anybody ever play Monopoly all the way through?
Um, my kids do.
All the way through.
Yeah. Um, I haven't played Monopoly in a long time. There are reasons that I don't love the game. I play
Probably
it for nostalgia, but
probably
not.
because it's not such a fun game.
Yeah, the game that I'm thinking. Yeah, well, there are a number of issues that make it anyway.
I seem to
The
recall
game.
that I seem to recall that somebody once told me that the original motivation for the creation of the game Monopoly was to prove the futility of capitalism.
Yeah, well, it's not pure capitalism. So yeah.
Anyway,
Anyway, so the game that I'm going to pick is called Letters from Whitechapel. And I understand it's like Scotland Yard, but I've never played Scotland Yard. So one player plays as Jack the Ripper, and then the other players play as the police deputies. So they're trying to catch Jack. Um,
is it kind of like
and
Clue or something?
no, in the sense that you're not trying to figure out who did it or anything like that. It's literally so what the way it works is you have the women that Jack the Ripper kills, and so when he murders somebody, I just dropped the link, but I didn't label it. When he murders somebody in the game, he has so many moves that he can make to get back to his hideout, and you play it in 5 rounds. And so the police deputies are trying to block him off, and so they'll go investigate different spots on the board, and there are hundreds of spots on the board. And so they'll investigate a spot and they'll either find a clue, which means that Jack was there. And Jack writes down when he moves through a space, he writes it down on his thing. And one of my favorite things to do when I'm Jack the Ripper is actually to loop back around. And so they'll find clues. They'll find clues all around this spot where I went through twice. And so then they don't know which direction I went coming out of there. But anyway, if you manage to get back to your hideout after all 5 rounds, then you win as Jack the Ripper. And then if the deputies investigate a spot and Jack's there, and they have to specifically say that they're staging an arrest at that spot, that if they do that properly where Jack is at, then they win. And
I have to
so
tell you
go
that
for 5 rounds.
the subject matter seems a bit dark for a game. I have to tell you.
It is, but the overall gameplay is fun. And so what happens is you start to narrow down where the hideout is, right? And so you can then start to you know where he's going, and so wherever the murder happens at, right, then you can start to kind of fan out along where he might travel through, and get a sense of where he's at, and then be able to arrest him. And so that's kind of the gameplay. Let me look it up on Board Game Geek so I can get the weight. The reason that I haven't finished it is I tried to play it with my family, and it's kind of a longer game. I mean, it can run like 2 hours or longer. And so they just kind of, especially my kids, just lose interest. And it's not the kind my wife likes to play the kind of light, airy games. And this one's a heavier game. And so, all the strategizing and stuff, she just doesn't love. It has a board game weight of 2.64. So it is on the heavier side of a game that a casual player would play. But anyway, it's a fun one. So I'll pick Letters from Whitechapel as my board game pick. And then I've been doing a whole bunch of stuff with just being more. I took way too long on that pick. So I'll be brief on these other ones. I've been trying to be a little bit more efficient with my time. And I've also been working on getting back into shape. So, I picked a marathon and started training for it. So a few picks that I've got here that I'm just going to put out there. So my training program I do in Training Peaks, and that's just trainingpeaks.com. I'm going to put it in the comments as well. And effectively, it just gives you a calendar. You can buy workout plans. The ones I've bought cost anywhere from $5 all the way up to like $50. I think the marathon and triathlon ones were more expensive, but it literally just puts the workouts into your thing. And then I have a Garmin Forerunner watch, and so it just syncs it down to my watch. So all I have to do is tell it, go into my training calendar, pull the workout, run it through the watch. Right. So I did that this morning, went for a run. It was awesome. As far as being more efficient, I've also picked up and been using Linear, which seems to be pretty popular in the development circles. It's linear.app. I'll put that in the comments as well. And it's basically a project management board like any of the other ones that you're used to. And then what I've been doing is I've been anything that I intend to do anytime soon out of Linear, or if it's other stuff that I need to be doing, like, for example, when Dan and I were talking before the show, he was like, hey, we ought to get people like this on the show, or, hey, I was going to reach out to so-and-so, and I was like, oh, I know them. And so as we were having that conversation, I put them into another system called Motion. And I kind of, I'll look and see if they have an affiliate program, but I'm just going to put the link in. It's usemotion.com is the app. And the way that this works is, so you put your tasks in. Let me put it, usemotion.com. Sorry, I'm typing and talking at the same time. So you put your tasks in, and then it pulls from my Google Calendar. And so it knows when I have something scheduled, like this episode. And then what it does is it says, okay, I'm going to put the other tasks that you've put into Motion into your calendar. And so, and you can set it up so that it'll actually add them to the Google Calendar, which is what I did. And then I told it not to mark it as busy. So they show up as free time. So it's got tasks set up for Tuesday, Wednesday, Thursday, and Friday this week as well. But they show up as free time. And so what that means is that if somebody books a time on my calendar, it'll just shift everything around it. And so it essentially tells me what to work on. And then finally, the last thing that I've been using is focus blocks. And I'm actually going to do another premium episode with Manny, who's the guy that created it. But effectively what it does is you get on you get on a Zoom call, and that you do a breathing exercise before you start, and you commit to, this is what I'm going to do this hour. And sometimes I hit it and sometimes I don't. And it's things out of my control, or it turns out to be harder than I thought it was going to be, or whatever. But it keeps me on task, because what they make you do is they make you put your phone away from your desk, and so you focus on it. And then at the end of the hour, you do another breathing exercise. You report on whether or not you got your thing done, and then you do it over again. And I usually get 2, 3, 4 focus blocks in an afternoon. I try and schedule all the regular stuff in the mornings. But yeah, I'll do that in the afternoons, and then yeah. So a lot of my like prospecting, so if I'm trying to find sponsors or stuff, that's on there first thing in the morning. Getting through my inbox is a first thing in the morning thing. So after I go for a run and things like that, that's what we do. So anyway, those are my picks. I think it's focusblocks.com. And I know I have an affiliate link for that, but so we'll put that in the show notes, and it doesn't cost you anything extra, but I get a kickback if you use it. But ultimately, I mean, if these things save you a bunch of time and make you more effective, great. And then if I get a kickback because I found an affiliate link for it, even better. But ultimately, this is what I'm using. So, yeah, that's what I've got for picks. So we'll wrap it up. Until next time, folks, Max out.